Testing is a powerful tool in fighting any outbreak because it provides the vital data needed to track the spread of the virus. One of the problems is that it's really hard to tell from symptoms if you have the new coronavirus. So even if you do have a fever and a dry cough, those symptoms could be caused by lots and lots of other viruses. So the only way to be sure is through testing, but it's much easier to talk about testing than it is to actually do it. In the UK, the current test that the NHS uses for the new coronavirus is actually looking for the genetic material packaged up inside it. Step one of the test is to get hold of some virus. We know that it attaches to receptors in the mouth and down into the airways. So the best way of getting hold of a bit of it is to swab the tonsils and get some snot from the nose. And what we've got there is a very small amount of snot, saliva, and if I was infected, we'd have some virus there as well. And there's a clever way to detect even minuscule quantities in the lab using a technique called polymerase chain reaction, or PCR. So this is my sample here, and if I had coronavirus, there would be a very small amount of virus genetic material on the end of the swab. So I could get that out, and I would put it in a tube, something a little bit like this. The tube would contain a cocktail of chemicals that can locate any strands of viral genetic material in the sample and multiply them. Inside the PCR machine, the tube is heated and cooled repeatedly. Each cycle doubles the number of strands, and after about 30 cycles, one strand can become over 1 billion, making the virus easier to detect. This test is amazingly sensitive at turning a very small amount of genetic material into a very large amount. This is how millions of people across the world have been tested so far. It's the gold standard, but there's a catch. It needs scientists and it needs complex equipment, and crucially, it takes quite a long time, about 2.5 hours just to run those cycles. So what we need is a much faster test, because we are going to have to test tens of millions of people in the coming weeks and months. Luckily, there's a shortcut. A team at this Oxford University lab hopes to dramatically cut the time it takes and the need for expensive kit and trained professionals. They're trialling a testing technique that's been around for 20 years and might now be repurposed to detect this new coronavirus. Biomedical engineer Dr. Jane Cha-Chin Shi is working on the project.
So I got two samples. One is a positive control that contains viral genetic materials, and the other one is a negative control.
So basically, it's a positive control to make sure that the test is able to detect virus, and then you've also got a negative control to make sure that the test doesn't detect virus when it's not there.
Yeah, that's correct.
Inside the tubes is a pre-mixed soup of chemicals, similar to those in the PCR test. The difference is that this team has developed chemicals that can locate the viral genetic material accurately and multiply it without the need for repeated reheating. So this test can be kept at a constant 65 Celsius for just half an hour. If the virus is present, there'll be a color change.
So after 30 minutes, we can see that the positive control has already changed the color into yellow, while the negative one remains pinkish.
So this is amazing. All you've done is get your pre-mixed tubes, add the sample, put it in the heat block, and then you can just look at the tubes and go, yep, that one has coronavirus and that one does not.
Correct.
Jane and her colleagues believe that this novel test is so simple they can turn it into a kit people could do at home, using nothing more complicated than a hot drinks flask. So once you've perfected this method, if you sent me a tube at home, I could get a swab, put it in the tube, and then I could just look at the colour result myself.
Yep, that's our ultimate goal.
The process still needs to go through stringent trials to make sure the chemicals used are very precise at locating the coronavirus genetic material. The hope is that this test, or one of dozens of similar tests being developed around the world, could be available in the near future. All of the current tests will tell you if you currently have the virus, but attention is now focusing on another type of test, known as a serology or antibody test. And that will tell you if you've ever had the virus in the past.